Hello, Geometry Land! We are continuing our adventures with circles. Today we are on lesson 10.2, finding arc measures. Oh, that might be a little dark. I hope that's better. So we're going to talk about arcs and angles in circles. And so there's some more vocabulary and some more naming that we need to go over. We actually haven't named arcs before, so this is going to be new. So first of all, a central angle. All right, a central angle is an angle whose vertex is at the center of the circle. I know, shocker there. Central angle, center of the circle. A minor arc. All right, a minor arc is an arc on a circle that measures less than 180. It's named by its endpoints. All right, it's named by its endpoints. A semicircle is an arc on a circle that measures exactly. All right, it measures exactly 180 degrees. It is named by its endpoints and one other point on the arc. All right, its endpoints are the diameter of the circle. Its endpoints are the diameter of a circle. A major arc, an arc on a circle that measures greater than 180 degrees. It is named by its endpoints and one other point on the circle, or on the arc. Excuse me, one other point on the arc. So let's take a look at our first circle right here. We have circle C. That's how we would name it. We would name it circle C by its center point, circle C. So a minor arc, an arc that is less than 180, would be arc AB. And to do a little arc, we draw kind of, an arc on top of the AB there. So it looks like a little half circle almost, or just a little swoosh. A major arc would be an arc that is bigger than 180. So we have our minor arc here, which is this guy. So that means we only have one other arc on this circle, and that would be this one right here. That would be our major arc. So to name that, I need to have my endpoints, which are A and B, and one other point on the circle, which would be D, or on the arc, I should say. So this would be my arc, ADB. So the more letters it has, aka if it's got 3 letters, it's a major arc. If it has 2 letters, it's a minor arc, right? 3 letters means it's bigger than 180. 2 means it's less than 180. So let's take a look at, I'll draw a little line here, at circle S. Circle S. Let's see if we can name some minor arcs and some major arcs and semicircles if we have any. Let's see if we can name some semicircles. So minor arcs would be RT right here. Arc RT would be a minor arc. We also have arc TU right here. Arc TU or UT, right? It doesn't matter the order that I put these. Just like it doesn't matter when we are naming line segments if we name it AB or BA. Same thing with radii, right? It doesn't matter if we name it SR or RS. It's the same segment. So these are our minor arcs, RT and TU. Let's look at some major arcs. Well, I have one major arc right here, right, where I have arc TRX. TRX would be a major arc. Another one that we could do would be TUX. That would be another major arc. TUX. Since we're not doing any formal proms or anything like that, let's throw tux into our life these days. We could even do an arc of RUX. That guy right there. RUX. That would be another one. So we can name a couple more if we wanted to, right? But that's a good idea of some major arcs. So semicircles are the last one. Semicircles are major arcs, but they are special because they form exactly half the circle, right? Their endpoints are on a diameter. So we have our U right here that is a diameter. TS we know is a radius. So a semicircle would be RXU. That would be one option for a semicircle, RXU. You'll notice that my diameter is the endpoints, right? So just like we name angles, right? My endpoints. And another semicircle would be in the other direction, so going this way. So it would be RTU. RTU. So that's how we name arcs. That's the kind of arcs that you can expect: minor, major, and semicircle. Now, how do we measure these? That's the next question we need to ask. How do we measure these? So for measuring minor and major arcs, a minor arc is equal to the measure of the central angle. All right, a minor arc is equal to the measure of the central angle. So in this case, our minor arc for this circle C here would be EF. So arc EF, it's equal to the central angle. Well, if central angle is 125, that means the measure of the arc is 125 degrees. So let's look at the major arc now. Okay, major arcs are measured, are equal to the difference, of 360 and the related minor arc. So I know that arc EGF, and be very careful because EGF is this arc, EFG would be that arc, right? Those are very different. So arc EGF would be equal to 360 minus arc EF. Well, that would be 360 minus 125. So the measure of arc EGF would be 235 degrees. All right. Now, the arc addition postulate. This is one of those ones that you kind of look at me and you go, well, duh. And that's okay, but we still need to go over it. So the measure of an arc formed by two adjacent arcs is the sum of the measures of those two arcs. So let's just say we were looking for the measure of arc ABC. So that's this guy right here. So it would equal the sum of arc AB plus arc BC. That's all this guy says. It's going to equal the sum of the two arcs. All right, the next one, congruent circles theorem. I'm going to slide this up so it's easier for us to read. Congruent circles theorem. There we go. Two circles are congruent if and only if they have the same radius. All right, if and only if they have the same radius. So if AB is congruent to CD, then circle A is congruent to circle C. And remember, we name circles by their center point. Again, this is a little bit of a dull one, right? If they have the same radius, then of course they must be the same size. So the circles are the same. The next one that we're going to talk about is the congruent central angles theorem. All right, congruent central angles theorem. And this actually harkens back to Chapter 3 when we were looking at parallel lines and all those sorts of naming angles and things. So the congruent central angles theorem says in the same circle or in two congruent circles, two minor arcs are congruent. So our minor arcs are BC and ED here. If and only if their corresponding central angles are congruent. So I'm going to name the angle. We've got angle BAC, right? Angle BAC is congruent to angle EAD. Angle EAD. I know that because they're marked. It's given to me. I've got little whooshies here. Well, that means that arc BC is congruent to arc ED. And this makes sense because if this angle here is 30 degrees, let's just say, that means the arc measure here for BC is 30. And these are vertical angles. It's another way of thinking about it. These are vertical angles. If we were back in chapter 3, that's what we call them. So let's take a minute and let's actually find some arc measures in our circle C here. So the first one we want to find is HI. HI, well, it's going to be congruent to its central angle, which is 35 degrees. Next one we want to find says HK. HK. Well, we know that IHK is 180. And then if we subtract 35 from IHK, we should get just HK. So that means that this one is 145 degrees. So that's our measure for HK. HJ. HJ is this one right here. Well, HJ would be made of HI plus IJ. So that would be 35 plus this right here means 90. So it should be 125 degrees. Next, we need JKH. So that's this one right here. JKH. Well, this would be equal to JK plus KH. I forgot my arc symbols. JK, we actually know. If this one's 90, what must JK be in order for this whole semicircle to be 180? This guy has to be 90 as well. And then HK, we just found up here, it's 145. So that means we have 235 for our arc measure for JKH. Next, we need KHJ. KHJ. I have a couple different ways of doing this. I could add our KH arc plus HI arc plus IJ arc, or if you could do 360 and subtract your KJ. Because I'm looking at everything except for this section, we just said KJ was 90, so it would be 360 minus 90, which gives us 270. 270. The very last one is IHK. IHK is a special semicircle. So automatically you know it is 180 degrees because I and K lie on the diameter. I have included an entire second sheet that is just practice, all right? This is full of just practice for you. And you'll notice down at the bottom I have included all of the answers. So you are welcome to try this out. It is extra practice for you. Expect a quiz to be posted in the next couple days going over arc measures and special lines and segments in circles. Big Idea Skills Practice is posted.